Good, good day. Well, it's early morning for me, about 10:30. So today's demo is going to be the unicast communication would be one-to-one. A broadcast would be one to all, and then a multicast, which is a one to many. So that's how devices communicate. The most efficient way would be the one to one, but that's not always possible. So let's take a look at the green area here. The original networking was a hub environment, which a hub is a non-intelligent device. So whatever goes in the hub is an echo box. It would floods out all the ports except the one it was received on. So this is the original networking. So the hub was designed to just connect multiple computers in one area. And then they found out how bad the communication process was. So let's try to do a unicast from PC5. So if I hold my mouse over the PC, I should get my layer 2 and layer 3. There it is. Fast Ethernet 0, 192.168.108, 24-bit mask, and then your gateway is 1.253. And if we go over to PC 20, it looks like it's 1.5. So let's go ahead and go to the desktop. Command prompt. I'm going to go to simulation mode so we can see what's going on with the protocols and what layers. I'll speed up just a little bit. So if we're in here, we're going to ping 192.168.1.5. So we press enter. We look at the first. So we're looking at a ICMP protocol. Resize this here. All right, so it only goes up to layer 3. So the ICMP is only the 1, 2, and 3. So when it goes into the hub, we should expect it to flood out all ports. I'll pause it there. And now you see we have a lot of collisions going on with the red X's. So we still have a lot more area to cover here. So let's watch the process. So remember, it's going to keep echoing. So now another echo, and we have another set of collisions. So I believe that's up to about 12 or 13 collisions right now. One more set of hubs to go. And notice that the one that needed to answer, so every one of these devices were contacted and only one of them actually needed that information. And you can see it continues to go on. And if you let it play out, it'll just continue to do it over and over and over with all these collisions. So broadcasting is necessary for a few things, but it's very inefficient. Let's go to the unicast. So let's now just ping from PC1 to PC2. So 172.16.1101. So let's go to desktop again, get into simulation mode. Command prompt, ping 172.16.1.101. We hit enter. We can see that we now have, once again, ICMP. So to layer 3, you have your IP address source and your destination. And layer 2 and 1 are grayed out because at this point we're at layer 3. So it goes into the switch. So we look at the switch, we should expect layer 2 information, which is your MAC address. And both MAC addresses are the MAC address of the devices. goes across. Notice that it didn't go down to 192 or the 172. So it went into the device and did not flood. It went straight across. And once again, Streamline Unicast. So Unicast means one-to-one, and no other devices will be involved in that communication. So no wasted bandwidth or device resources. Okay, so that's also kind of an example of a multicast, because we only ping from one device to the other. Now, what I'm going to do next is do a broadcast. So unicast was one-to-one. Now a broadcast is one to all. So to do a broadcast, you can ping the last IP of the IP scheme. In this example, we're going to ping 172.16.1.254. Now we have some 192s mixed in. So you can see PCs here with 192. Will or will they not get this broadcast? So I'm trying to send a broadcast across the network. Will it go to the 192 numbers also? 255, which is the last number we can represent in binary. Let's go to simulation mode. ICMP up to layer 3, but notice layer 2. You have a MAC address and then FFFF. That is a layer 2 broadcast. So that's something we need to identify. So now we're in a switch. Once again, we still have FFF in the destination, but now we're seeing IP address. But look at the IP, 255, 255, 255, 255. So that's also a broadcast. So it goes across the link. So it only went down to the 172. It did not go to the 192. So we can expect it to only go to the 172 on this side. And there you go. So this is a broadcast, but also kind of a multicast at the same time. So multicast is one to many, but this was one to all only for that little network. All right, so demonstrate this again. Let's ping from the 192 network. Let's see if we can do 255, 255, 255, 255. Let's see if that'll work, because that's the last IP available. 255.255.255.255. Now, if this works, it should go to every device, no matter what the IP is. Typo? So you can't even type that. So let's just go ahead and ping the 192.168.1.255. Arrow up, put ping in front of it. Okay, so now once again, ICMP, we see the IPs. We see one IP and then a 255. Then we see one MAC address with the FFF. So that's definitely a broadcast. So it goes into the switch. Should go out only to the 192, which it did. So it avoided the 172 network and down to the 192. Okay, so that is your unicast, your hubs broadcasting, and also a broadcasting with the last IP. So in this environment down here, we're going to see what will ping. So we kind of see something different. We see a 172.16.114 and a 255, 255, 255, 240. So remember, the subnet mask controls the start and the end and how many devices. So what we're going to do is ping .1 first. Let's go to simulation mode. Back to command prompt. Ping 172.16.1.1. Once again, we go to simulation mode, look at our protocol. We see an IP source and a destination. So it goes into the switch. So it looks like the ping's working. Okay. So back to real time. And you can see we have our replies here. or sent or received, 0 loss. But let's ping this 100 number. So I'm going to arrow up and just put 100. I'm going to go back to simulation mode so we can actually see what's going on. And then press enter. Once again, we just have a type message. So it's not going anywhere. So let's take a look. Timeout, timeout, timeout. So what we're saying here is 1 and 14 are in a network, but .100 is not in the same network. So that's what we're going to learn in a couple chapters about how to distinguish against the subnet mask in the IPs. So that concludes our video with unicast, broadcast, and multicast.